We are now going to apply writing equations of lines to an application problem. So we've got a manufacturer buys a new machine costing $120,000. It is estimated that the machine has a useful lifetime of 10 years, and at that point in time, it's going to have a salvage value of $4,000. So we've got two quantities that we're talking about. We're buying the machine new, costing $120,000. Then at 10 years of age, it has a value of $4,000. So we're talking about age and value. So I need to figure out which one depends on the other. Does age depend on the value? Sounds kind of weird. Or does the value depend on how old it is? And it's this one. The value depends on the age. Now remember, your dependent variable is y. So that's your y. So y depends on x. And you usually have an ordered pair that shows that. So what is our y value? Well, y is going to stand for the dollar amount that the machine is worth. So I'm going to put dollar value. And our x coordinate is going to stand for the age of the machine in years. Now when it says what 2 points are given in this situation, I can go back to the problem and say a new machine costs $120,000. And after 10 years, it's worth $4,000. So new means its age is 0. And its value is $120,000. Notice how I'm not using commas in my numerical value, $120,000, because it might get mixed up with this comma. So I don't put any commas in my numbers. Okay. The second ordered pair, that's 10 years old, and it's worth $4,000. Now, given two ordered pairs, we can write an equation of the line. And that's what B is asking us to do. It says find the value of the machine after T years, where T has a lifetime from 0 to 10. So where equations of lines produce a graph where you have arrows at the end, this is going to have a limited domain where it's going to have an endpoint and an endpoint. So finding the value of the machine after T years, that just means write the equation of the line. So find the linear equation. So in order to do that, I need to find the slope. So the slope is going to be 120,000 minus 4,000 over 0 minus 10. Well, 120,000 minus 4,000 is 116,000 divided by negative 10. The zeros cancel out, and my slope is negative 11,600. Now, what's kind of nice about this problem is 0, 120,000 is the y-intercept. And the y-intercept, the y value of the y-intercept, is our b in y equals mx plus b. So we've got a slope right here. We've got our slope. We've got our y-intercept. We can write the equation of the line pretty simply here. Y equals negative 11,600. Matter of fact, I'm not going to use y. And the reason I'm not going to use y is because as I was writing it, I recalled that they're not going to let us use x for time. So normally we use x and y, right? But they want our number of years to be time. So since we're changing the variable from x to t, I'm going to make this more relevant and make my value V. So my time in years is going to be T, and my value, my dollar value, is going to be V. So instead of Y equals, I'm going to have V equals negative 11,600 T plus the y-intercept of 120,000. 1, 2, 3, yep, 120,000. So there's our value in terms of T. Okay. Now we're going to use that equation to find the value after 8 years. So the value after 8 years is going to equal negative 11,600, which means negative $11,600 every year, because our value was in the numerator and our time in years was in the denominator. So we're losing $11,600 in value every year. We're going to lose that for 8 years. So I'm going to put an 8 in for time. And then I've got to multiply 11,600 times 8. And I get 92,800. So negative 92,800 plus 120,000. Now I'm being stubborn right now and not picking up a calculator. But if you have a calculator, you're more than welcome to do this math on the calculator and maybe save me. So this 20 is going to become 19. And then I'm going to, actually, this 2,000 is going to become 1999. Nope. Let's try that. I better use a calculator, right? Okay, let's get as far as we can. 0 minus 0, 0 minus 0. Okay, this 20, back to where I was, is 19. And then I'm going to put the additional one right there. 10 minus 8 is 2. 9 minus 2 is 7. And then I've got 11 minus 9 is 2. So I believe that my value is going to be $27,200. But you go ahead and check in your calculator. Okay, so that's the value after 8 years. So you might want to, since it's got a salvage value of $4,000 after 10 years, you might say, hey, I need the cash. I'm going to get rid of it now because I don't use it that often. I'm going to bank the $27,200. Now, this problem continues. So I'm going to write the equation up here. V equals negative 11,600 T plus 120,000, in case I need that. Calculate the T intercept. The T intercept, okay, so T comma V. The T intercept is the value of T when the value is 0. So 0 equals negative 11,600 T plus 120,000. I'm going to add 11,600 T to both sides. And then I need to divide by 11,600. And I'm going to get T is approximately, I encourage you to pick up your calculator now. So pick up that calculator and most definitely divide, because you know that I'll make a mistake. Okay, I divided it out and I got about 10.345 years. So time is approximately 10.345 years. What does that mean? 10.345 comma 0. Well, the value will be 0 after 10.345 years. That's exactly what it means. So calculate the t-intercept. So here's your t-intercept right here. And what it means is after 10.345 years, machine is worth $0. So you most definitely want to get rid of the machine after 10 years so that you can at least get $4,000 for it. So what's the domain of this function in interval notation? Well, you'd think that it would be 0 to 10.345, but back here they actually gave us the domain. They said the domain is from 0 to 10. So I'm going to write it was given, and in interval notation it goes 0 to 10. So let's think about what this looks like graphically, okay? Graphically, I have an ordered pair 0, 120,000, right? So that's where your time starts, when time is 0. And then at 10 years, because it was given at 10 years, it's worth $4,000. So it's got a beginning and an end. Now, I don't ever get to the T Intercept. This is kind of cool right here. I don't ever get to that T Intercept of 10.345 because the given domain was 0 to 10. Kind of cool stuff there. Okay, in the next video, we're going to do our last problem for this lesson, which is going to talk about marginal cost. Marginal cost. So that's what's going to be new for you right here, is this marginal cost. You'll probably be able to do A and B, and you might be able to figure out C, but I'm going to explain what marginal cost is in the next one.